A second way to name points in the coordinate plane is with polar coordinates. Polar coordinates are a little different than rectangular coordinates, and in this section we want to look at how we convert back and forth between them. But first of all, let's take a look at how we graph some ordered pairs in polar coordinates. So I want to graph in polar coordinates the ordered pair 2, 135. So this is the distance out to the point that's on the terminal side of this angle in standard position. So 135 in standard position is going to be the angle that the terminal side of the angle will be along this line right here, and I want to go 2 units out on that. Well, you can see that my units are 1, 2, and 3. So on this line right here, I'm going to go out 1, 2 units. I'll be at this point right here, which is the point 2, 135 degrees in polar coordinates. So in polar coordinates, the first number is the distance out to the point, and the second number tells you the angle in standard position along whose terminal side you travel to get to the point. Let's look at the next one. I have the point 1 and negative 135 degrees. Well, if this is 0 right here, negative 135 is back this way, and that's this angle. And so I want to go 1 unit out on that angle, which is negative 135. So negative 135, and then I want to travel out 1 unit. That's this point right here. So there's the point 1, negative 1, 135 degrees. Next, I have negative 2.5 and 45 degrees. So here's 45 degrees right here, and now this time I want to go negative 2.5 units on that. So that's negative 1, 2.5. That's that point right there. Let me do that in red. That's this point, which is negative 2 and 45 degrees. So I can have positive and negative numbers for both r and theta. Remember, angles are measured positive when I go in a counterclockwise direction and negative when I go in a clockwise direction. So here's the point that's 2 units out on the terminal side of 135 degrees. This is the point that's 1 unit out, 1 unit out on the angle in standard position negative 135. And this is the point right here that's negative 2 units out on the angle 45 degrees. So instead of going forward along 45 degrees, I go back negative 2 units on its projection back to the origin like that. Let's look at another problem. What other ordered pairs name the same point as 2, 60 degrees? Well, let's take a look first of all at the graph of 2 and 60 degrees. I want to go 2 units out on the terminal side of angle 60 degrees in standard position. So I'll go 2 units out, 1, 2, on an angle of 60 degrees in standard position. So this is the point right here, 2, 60 degrees. How else can I name this point? Well, I could say, let's say, I'll name it with a negative angle. I'll get to that angle this way, which would be, let's say, 2 units out on the angle negative 300 degrees in standard position. So this angle is negative 300 degrees, and all I have to do is go 2 units out on that. How about if I also said, okay, I'm going to go over here to, let's see, this angle right here, which would be negative 120 degrees. I could use that angle, and then I could go back 2 units on that. So how about negative 2 units out on negative 120 degrees? Would look something like that. I could also say, how about this angle right here? That would be the angle, what, 240 degrees? And I could go negative 2 units out on it. So negative 2 and 240 degrees. Now, I could also add on 360 degrees to any of these angles right here and name another ordered pair that named this same point right here. So this is one of the things about polar coordinates that's different than rectangular coordinates. Different ordered pairs like this can name the same point. So each point does not have a unique representation in polar coordinates. Let's go on and look at our next problem. This time we want to convert from polar coordinates, square root 2, negative 135 degrees, and into rectangular coordinates. So what I have is this. R is equal to square root 2. Theta is equal to negative 135 degrees. And here's my conversion equations. X is equal to R cosine of theta, which is square root 2 times cosine of negative 135, that's going to be negative 1 over square root 2, which comes out to be negative 1. So square root 2 times negative 1 over square root 2 is negative 1. Y is equal to square root 2 sine of theta. So sine of negative 135 degrees, square root 2 times the sine of negative 135, the reference angle is 45 again in quadrant 3, negative 1 over square root 2. I multiply those out and I get negative 1. So this point, square root 2 and negative 135 degrees in rectangular coordinates is the point negative 1, negative 1. So if we were to graph this point, negative 1, we would see that it also can be named by going square root of 2 units out on the angle negative 135 degrees in standard position. So it'll end up in quadrant 3. Its coordinates will be negative 1, negative 1. Here's another problem. This time we want to go in the other direction and convert from rectangular coordinates into polar coordinates. From this ordered pair in rectangular coordinates, I see that x is equal to negative 2 square root 3 and y is equal to 2. So to write polar coordinates, I need r and theta. I know that r will be the square root of x squared, so 4 times 3 is 12, plus 2 squared, which is 4. That's the square root of 16, which is going to be 4. To find theta, I'll note that cosine theta is equal to x divided by r, so negative 2 square root 3 over 4, which is going to be negative square root 3 over 2. And sine theta is equal to y divided by r, so 2 over 4, which is equal to 1/2. So I can tell because theta is equal to 1/2 that the reference angle for theta is going to be 30 degrees. Then I look and see cosine is negative and sine is positive. When cosine is negative and sine is positive, I must be in quadrant number 2 with a reference angle of 30 degrees. All of this together tells me that theta is equal to 150 degrees. So I want to name this ordered pair negative 2 square root 3, 2 in rectangular coordinates, in polar coordinates as the point 4 and 150 degrees. So if I want to get to the same point that's named here in rectangular coordinates using polar coordinates, I'll go 4 units out on an angle of 150 degrees in standard position. So 2 problems right here. One, we start with polar coordinates, change to rectangular coordinates, and then the next one we start with rectangular coordinates and we change to polar coordinates.